Ladies and gents, welcome back to our continuing astronomy discussions. Today, Walter and I are going to, well, maybe just me. Oh, hello. We're just going to have a brief discussion about dark energy. Last time, it was dark matter. This time, it's dark energy. Yeah, Walter, dark energy, right? Do you know all about dark energy? I know about Oreo energy, he says, black and white, right? All right, so dark matter, and there he goes. Dark matter constitutes about 75% of the matter of the universe. Some estimates go 85% of things that create gravity, okay? About 25 to 15% or so is the kind of matter we can see. Suns, moons, galaxies, planets, nebulas, black holes, neutron stars, all the heavy things, right? Even if they're wispy and thin like a nebula, the things that have mass, that is a small part of the matter, the gravity creating matter in the universe. Okay, so change gears now to the other thing we have an abundance of in the universe other than mass. I'll give you just a second to think about what that might be. So we have mass. Time is marching forward, of course. The Big Bang started that. But there's something else there is an abundance of in the universe. And every time you go outside, you feel it in some form or another. Ideas? If you're thinking energy, that's it. Okay, so energy. The universe is made of mass and energy. And thanks to Einstein and E equals mc squared, energy and mass are interchangeable. Sometimes it can get really violent. Sometimes time can do some wonky things. But E equals mc squared holds up in almost every situation around the universe. Let's talk about the energy part today, the dark energy. Again, we're not really sure that it is energy. It could be some force or some aspect of reality that we haven't yet properly described. It could be energy. It could be something slightly different or very different from energy. So dark energy is what we'll talk about in a little bit more detail right now. Dark energy is another one of those code words for our ignorance. Dark matter is, there's gravity out there. We don't know what it is. Matter makes gravity, so we'll call it dark matter. It really is a code word for our ignorance. And as Dr. Tyson would say, might as well call dark matter and dark energy Fred and George for all that we know about them. We just don't know what dark matter and dark energy are, but we can see their effects. This is where we really find deeper meaning in a mystery, even if we don't understand why it is that way. Okay, dark energy. Students in my astronomy class, we've talked about this briefly. We've talked about how the universe is going to end. Will it end all coming back together again? Will it end where things expand out and reach a point and stop and just stay in that location forever? Unlikely. Or do they continue expanding outwards and hit the cruise control and stop accelerating or slowing down? They're not going faster or slower. Or do they move faster and faster? Like a car with the gas pedal all the way on the floor, and it's just accelerating uncontrollably faster and faster and faster. Those are the four basic possibilities. And this is what gave rise to the idea of dark energy, is within the last 10 years, they have figured out which of those four possibilities actually is going to be the final result in the universe. Let's go through them one by one, and then we'll talk about what we know, which gave rise to the idea of dark energy. Okay, so if the mass in the universe is heavy enough, all the stars, planets, black holes, galaxies, nebulas, comets, meteors, all that jazz, right? To where all the gravity is pulling on everything else, and the universe is expanding and it slows down because gravity is pulling, and it stops, and then it comes back together again like that. Started with a Big Bang, and then it ends with a big crunch. This idea gave rise to the idea, another philosophical mind-blowing idea, that the universe, if it survived a big crunch and then caused another big bang, could we have experienced this moment multiple times? Could we have experienced this moment thousands of times? Wherever you're sitting right now watching this video, could you have watched this video and thought about these ideas thousands of times already? Staggering to me to think that I've sat here and had my dog on my lap and now he's over there happily chewing on a chewy thing thousands and thousands of times. Why not, right? It's possible. Okay, so that's one possibility. Two, the least likely of all of them is the matter in the universe. After the Big Bang, the matter in the universe and the forces of the Big Bang itself balance perfectly. And I mean down to the atom. Balance perfectly. The universe expands out to a certain point and it stops. That's so unlikely. That's like winning the Powerball in the state of Utah. We don't have Powerball in Utah. So it's really, we can take that one off the table right away, okay? Is that the universe expands out and then eventually it settles down and comes to a complete halt and never changes after that. We can get rid of that one as laughably unlikely. Third possibility, the universe is expanding out and it hits cruise control. It's now a linear function of expansion. Everything is moving away from everything else at exactly the same speed, never speeds up, never slows down. It just hits cruise control and it expands equally in all directions, whatever that would mean. Okay, that's the third possibility, also unlikely. But the fourth possibility is the one that intrigues astronomers the most now. The idea that the universe is expanding and it's not just getting bigger, it's getting bigger faster. My friends, welcome to the idea of dark energy. Okay, so dark energy. What is it? Again, we don't know what it is. I wish I could say, all right, everyone, gather around. I've created a little reaction in our classroom, and the result, you could see the dark energy just cranking out forces in the universe. It's not something we can point at and say, aha, I found you. But it's something we can calculate based on how the universe moves. The objects that are physically the farthest away from us appear to be moving faster than the ones that are close to us. Like two ants standing side by side on a balloon. As the balloon blows up, the ants next to each other will come apart, a tiny amount as the balloon expands. But the ant here and the ant there, opposite sides of the balloon, will experience a much faster departure from each other than the two that are right next to each other on top of the balloon. That makes sense, okay? But within that expanding space of the universe, there are supernovas that serve as measurable light sources that are moving faster than we would have expected. The only logical conclusion to seeing that they move faster within the universe than they should, the universe is accelerating. It's getting bigger, but it's getting bigger faster and faster and faster. So what does this mean for the end of the universe? This is the part that Walter, come here. This is the part that Walter and I, come on, will describe for you. Lay down. Be a good boy. Lay down. Come on. Come on. Show my students you're a good boy. Stay. At the end of the universe, if everything's accelerating and flying apart faster and faster, that means galaxies will eventually be so far apart they're unaware of each other. Okay, like one galaxy will not be able to see other galaxies in their night sky. They will believe that their galaxy is the only one. That's a sad, lonely thought, but that's what the theory suggests. Well, what about stars in the galaxy? If everything is expanding apart and going faster because of this continuous dark energy, like this ball and the dog chasing it are going apart from me, even stars will drift apart until the stars are so far from each other that they were unaware of each other's existence. Then planets will drift away and be pulled away from their stars, give it enough time, right? And then, this is the part that's really mind-blowing. This molecule at the tip of my finger and that molecule next to it at the tip of my finger, eventually they too will be an infinite distance apart from each other. Atoms will be pulled apart so that the neutrons and the protons in their nucleus will also be an infinite distance apart from each other. After that, it's cold, it's dark, it's empty. Even the black holes will fade and vanish, thanks to Stephen Hawking's discovery of a kind of radiation that very slowly over time escapes black holes. We call it Hawking radiation. So even the black holes eventually will fade. Well, come on. Okay, so that is the end of the universe. That's the mystery of it all. Dark energy. We think something must be driving this acceleration. Because seriously, a car sitting on the street isn't going to go anywhere until someone pushes the gas pedal and makes it go somewhere. It accelerates and it drives away. Everything in the universe, thanks to Newton's laws of motion, an object at rest will stay at rest until a force acts on it. An object in motion will continue to be in motion until a force acts upon it. You ready for this to be in motion, Walter? Ready? Go get it. Okay, so there must be something making the universe accelerate faster. Some of my students in the past have very wisely described, what if it's the next universe over? In the multiverse theory, what if it's the next universe over that's pulling on ours and making it accelerate faster? Why not? I don't know how the multiverse works, how one universe can have an impact on another universe nearby, if there is such a thing as nearby. Who knows? But that's the mystery of dark energy. We don't know what it is. We know something is going on. We can't really point at it and say, aha, there you are. And we can't describe it. We can only see its effects, rather like dark matter. It's a mystery that maybe one of you will solve someday. Maybe one of you will figure it out. Maybe one of you will be able to say, yep, in this number of years, how many trillions upon trillions of eons in the future, the universe will end, and here's why. And if we figure out what it is, maybe we can do something about it. I don't know if we would want to, but why not, right? We think big. We're little people on a little speck of dust floating in the cosmos, but we don't think small. Okay, big ideas lead to even bigger and better realities. All right. Walter and I have taken up enough of your time. In the comments below, the description rather, take a look at the link that I put describing what dark energy is. And honestly, do we know much about it? It's a mystery, and it'll go on being a mystery until science has time to work its amazing things. All right, so keep working on your interactive notebooks. Please get through to page 65. Take pictures of both pages together. Take a snapshot of that. Email them to me, and so I can keep your grades caught up in the system, and you'll be all set to go. Thanks for watching, and we'll do another pick a card soon. And Walter, come on, boy. Yes. And Walter and I will be back for more on another day. Take care, friends.